this video, we're going to review the product rule. This is from section 3.4. And remember, chapter 3 was all about finding shortcuts to derivatives, to computing derivatives. Now, initially, if you remember, when we computed derivatives, we were always just approximating them, but getting better and better approximations. Remember, we were computing average rates of change over smaller and smaller intervals, and we knew that if we just made that intervals infinitely small, we would eventually get to the derivative. But, of course, doing that was pretty tedious. I mean, it's even pretty tedious just to say it. But anyway, we want to compute derivatives faster. And in this section, we're going to want to compute functions of this form that can be broken up as the product of two functions. And of course, this happens all the time because multiplication is just one of the operations you can do to get new functions from old ones. So the question in this section is, what's the formula for that? If I take f and g, two functions, I want to take the derivative of it, what's it going to be? And one might remember, if one had to guess, one might first remember what the derivative of f plus g would be if you just took the sum of two functions. And, well, that was pretty easy. It's just f prime plus g prime. It's just the sum of the derivatives. And so this might lead one to think, well, maybe f times g prime is just f prime times g prime. Turns out that that's completely wrong, and that's not what it is at all. Instead, what it is the following. So if I take f times g, and I prime it, I take its derivative, what you're really going to get is f prime times g plus f times g prime. So you see, it's completely different from f prime times g prime. You take the derivative of one, multiply it by the other, then add the other one and take the derivative of the other. So that was confusing the way I said it, so let's put it another way. Let's look at f as the first function. Let's look at g as the second function. Then how does the product rule go? It always goes derivative of the first times the second plus the first times the derivative of the second. Alright? So it's always derivative of the first, do nothing with the second, plus first times derivative of the second. And that's what the product rule is. So now we're just going to do a bunch of examples seeing how this rule applies. Okay? So let me just erase everything, but of course I'm going to rewrite that formula so we can all see it. Alright, so here we go. I'm going to put the formula here. F times g prime is equal to f prime times g. So derivative of the first times the second plus first times derivative of the second. And I'm also going to put here in the corner that it's not equal to f prime times g prime. Alright, just to emphasize that that's not the case. Okay? So let's do this example first. Really easy one. Let's start out with polynomials and power functions. So let's say that f of x, actually let's give it a different name. Let's say h of x is equal to x squared times x cubed plus x. Alright? I want to find the derivative of this? Well, look here. You have x squared times x cubed plus x. Those are two functions. This is the first one, and this is the second one. Okay? So how is h prime of x going to go? Well, it's going to go like this. Derivative of the first, there it is, times the second. Do nothing with the second. Plus the first times the derivative of the second. Alright? So notice I was just using power rule to take those derivatives. And now if we simplify this, we'll get 2x to the fourth power plus 2x squared plus 3x to the fourth plus x squared. And if you simplify that, that's simply 5x to the fourth plus 3x squared. Well, that plus didn't come out so right. Plus 3x squared. Okay, so you see that's the answer. Put a check next to that. And look at how this is completely different from, okay, so not equal to 2x times 3x squared plus 1. That's what you would get if you just took the derivative of the first times the derivative of the second. And that's going to give you 6x cubed plus 2x. So completely different from what the actual answer is. So I just want you to be clear with that. Don't take derivative of the first times derivative of the second. Okay, so I'm going to erase all this. Let's put up another example. One with slightly more complicated functions. So here we go, example 2. Let's instead do h of x equals x plus 1 ln x. Alright, so I want to find the derivative of h prime. Alright, here I can identify it easily as a product of functions. I'm going to make this one my first one, and this one my second. Okay, so h prime is going to be derivative of the first, that's just 1 plus 0, times the second, plus the first times derivative of the second, but derivative of natural log is just 1 over x. Alright, and so what do we get? We get ln x plus, well, distributing the 1 over x gives us x over x, which is 1, plus 1 times 1 over x, which is 1 over x. And that's what the derivative would be. Alright, notice how this is not the same as derivative of the first times derivative of the second. You see 1 plus 0 times 1 over x, that's just 1 over x. And then you're going to miss the ln x plus 1. That's way off. So this is not the right answer. In other words, it wouldn't be correct to do f prime times g prime. Alright, let's do one more example, one just a little bit more complicated. Here we go. Example 3. Let's do f of x, or sorry, rather h of x I mean, doesn't matter what the name is, but just to keep things consistent with how we've been doing them. Square root of x, e to the minus 2x, and that'll be our function. Alright, and this time I'm going to write the derivative like this, just so you kind of get used to this notation. What is d dx of h of x? Well, I'm going to do the same thing. I can view this thing as a product of two functions, a square root function right here. Let's make that our first. And this exponential function, let's make that our second. So we know there's a formula for exponential functions, right, with this continuous rate here. This is the decay rate, actually. And square root of x, that's just the power function, so we're just going to use power rule on that. But remember, it's the product of those two things, so how's it going to go? It's going to go derivative of the first, 1/2 x to the minus 1/2. Remember, why is that? Because square root of x is just x to the 1/2 power. So I'm just going to put that off to the side here. So power rule says it'll be exponent comes down, x to the 1/2 minus 1, that's negative half. So derivative of the first times the second, see, exponential e to the minus 2x, nothing happens there, plus do nothing with the first times the derivative of the second. Remember how that goes, minus 2 e to the minus 2x. And of course, if you simplify that, well, let's just look at this part here. Well, anyway, let's just write it out. We have 1 over 2, 1 over square root x, e to the minus 2x, minus 2 square root x, e to the minus 2x. And remember, the answer is not simplified if there's a square root in the denominator. And so we're just going to get rid of that really quickly. We can multiply the top and the bottom of this fraction, 1 over square root of x, by square root of x itself. So that square root of x comes to the top, and when you multiply square root of x times square root of x, you just get x. E to the minus 2x minus 2 square root x, e to the minus 2x. And if you want, you could even factor this, but let's just leave it like this. Alright? So, well, okay, let's just go do the final step. Let's factor, let's pull out e to the minus 2x, and so this goes away. We just pull it to the outside. Okay? And so that would be the final, completely simplified expression for the derivative. And you see, this is the product rule right here. This step right here. Let me just circle it. See, this was the product rule. The rest of these steps below, this was just simplifying. Alright? So the meat of the problem was here, identifying the products of the identifying which two functions were getting multiplied together, and then just applying the formula correctly when you take the derivative of the first or the second, for example. Alright? And remember, note that the product rule is not f prime times g prime. So this is a very common mistake, and it's a very natural one. Okay, that's true, but it's just not right. So just remember these things, these little sort of caveats, and you should be on your way.